we are going to see how we can create a sub-circuit in LTSpice that will allow us to import it to any other of our circuits. Let's say, for example, we have this circuit that generates a PWM signal. We want our sub-circuit to have a voltage input, call it VIN, that modulates the PWM and an exit for the PWM itself. In addition, we're going to be able to change some parameters in our sub-circuit. Those parameters are the frequency of the PWM, that essentially is a frequency of VRAM, which is the linearly increasing voltage. We want to be able to set the maximum value of this voltage, and we also want to be able to set the maximum voltage of the PWM. In order to accomplish that in LTSpice, we are using curly brackets. If, for example, we right-click on V1, which is a linearly increasing voltage, we are able to see various parameters. We said we want to set the maximum voltage of the linearly increasing voltage. To do so, we are placing curly brackets and a name. For example, VRmax. As mentioned, we also want to be able to set the frequency. So we are selecting T period, which is the period, and we must enter curly brackets 1 over F. F is the frequency. We are doing the same for T rise parameter, curly brackets 1 over F. We are selecting OK. By right-clicking on B1, we will change the maximum value of the PWM. We double-click and we replace the 5 with curly brackets, and let's select the name to be VPmax. We are selecting OK. Now, from the existing circuit, we don't need the 2, since it will be connected to an external voltage, and we can remove it. We also remove the tran command, and we can now save our circuit. File, save as, and let's select the name to be PWM, for example. We're selecting save. Now, we must also design the symbol for our sub-circuit. So we are selecting File and New Symbol. From menu item Draw, we are selecting Rect because we want our symbol to be a rectangle. We want to design this as symmetrical as we can, so it looks nice. Okay, let's design now the input and the output for our sub-circuit. From menu item Draw, we're selecting Line. The input and the output. Let's also place a text for describing this sub-circuit. Let it be PWM, and we're placing it somehow in the center. Now, we want to associate the input and the output with the equivalent nets in our circuit, which is the in and PWM. From menu item window, we're selecting Tile vertically to obtain a simultaneously view. From menu item Edit, we're selecting Add Pin Port. The first must be the in, so we're entering the in. We are selecting left, and we are setting the offset of the text to be more to the right. We are pressing OK and place it to the left edge of the line we designed. We are doing the same for the output, which is the PWM net. From menu item Edit, we are selecting Add Pin Port. We are entering PWM. This time we want it right, and again setting the offset to be 20. We're pressing on case and place it to the right edge of the line we designed. Now we are going to menu edit, attributes, and selecting attribute window. We are selecting each name and we are pressing OK. We place it to the above of the symbol we designed. This is the instance of every sub-circuit we are going to place to our design. 1, 2, 3, etc. We want now to associate with our symbol the parameters we want to be able to change. This is Vrmax, F, and Vpmax. In order to do so, we're selecting Edit, Attributes, and Edit Attributes. We are selecting Spice Line. We are entering the initial value we want. Let's say we want a frequency of 10 kHz. We are entering F equals 10K. We want the Rmax 5 volts, so we are entering the Rmax equals 5. And let's say we want the value of our PWM to be 5 volts. We are entering the Pmax equals 5. To the field value we are entering PWM and we are selecting OK. In order for us to be able to use our sub-circuit in another design, the file name of the symbol must be the same with our design. We have to select the name PWM, so we must save this with the name PWM. We are selecting File, Save As, PWM. We are not changing the extension. We are selecting Save. And let's now see how can we use this sub-circuit to another design. We are selecting File, New Schematic. In order to place our sub-circuit, we are selecting the component button, and for locating it, we are selecting from the top directory list LTSpiceIV, which is the directory we saved our symbol. We can see it, we are selecting it, and press OK. We are placing it, and we can see that the X1 is the instance of every sub-circuit we are placing. If we place another, it will have the value 2, 3, 4, and so on. We are removing the ones we don't need. OK. Let's place now a voltage source that will be connected to the in. We are changing the directory to the one before, and we select the voltage source. We will also place a resistor to the output and the essential grounds. We are designing the connections of our circuit. We are setting the resistor value to be 1K and the value of the voltage to be 1 volt. If everything is OK, by simulating the circuit, we must see a PWM waveform to the output. We are selecting Run, and let's say we want to simulate our circuit for 10 milliseconds. We are entering 0.01 and selecting OK. We can close the other windows now. We are selecting window tile horizontally and clicking to the output. We must see a PWM waveform. As we can see, there is a 0 to 5 volt PWM with a frequency of 10 kHz. In order to change some of the parameters, we must right-click to our sub-circuit and we can set our parameters. Let's say we want the output to be 7 volts and the frequency 5 kHz. We're selecting OK and we're again pressing run. We can see that the output went to 7 volts and the frequency dropped to 5 kHz. Let's now modulate the PWM with a voltage that increases and decreases linearly. We right-click V1 source and select Advanced. We are selecting Pulse and we want our voltage to increase linearly from 0 to 5 volts and vice versa. We want the time for the rise to be 5 milliseconds and the time for the fall to be 5 milliseconds as well. The period will be 10 milliseconds. We are setting zeros to the rest of the values and we are selecting OK. Once again, we are pressing run. We are clicking to the V1 source output in order to place it to the output diagram. We can observe that while the V1 is increasing, the width of the pulse increases as well. When V1 decreases, the width of the pulse also decreases. If we also change the limits of the diagram by right-clicking and selecting manual limits and set, for example, 8 volts, it makes it more obvious that while V1 increases, the width also increases. While V1 drops, the width decreases.